These variations on a theme are for SQL queries, and the first SQL query that we are going to look at is the theme left join. And without further ado, let's have a look at 3 questions pertaining to SQL queries. Customers who never order 183 flagged as easy. SQL schema. Suppose that a website contains 2 tables, the customers table and the orders table. Write a SQL query to find all customers who never order anything. Table customers, ID name, 1 Joe, 2 Henry, 3 Sam, 4 Max. Table orders, ID 1, customer ID 3, ID 2, customer ID 1. Looks like 2 and 4 are not ordering anything. Using the above tables as examples, return the following: Henry and Max. Next up, 184, department highest salary, medium, SQL schema, SQL scheme. The employee table holds all employees. Every employee has an ID, a salary, and there is also a column for the department ID. Look at that: ID, name, salary, department ID. 1, 2, 3, 4, 5, Joe, Jim, Henry, Sam, Max, 7, 9, 8, 6, 9, and then 1, 1, 2, 2, 1. The department table holds all departments of the company. ID, name, 1, IT, 2, sales. Write a SQL query to find employees who have the highest salary in each of the departments. For the above tables, your SQL query should return the following rows. Order of rows do not matter. IT Max, IT Jim, sales Henry, and then with the salary. Explanation: Max and Jim both have the highest salary in the IT department, and Henry has the highest salary in the sales department. And number 3, combine 2 tables, flagged as easy, SQL scheme, person. Column name and type, person ID, first name, last name, int varchar varchar. Person ID is the primary key column for this table, and then you got address, column, name, and type. Address ID, person ID, city, state, int varchar varchar. Address ID is the primary key column for this table. Write a SQL query for a report that provides the following information for each person in the person table, regardless if there is an address for each of those people. First name, last name, city, state. And all of those questions kind of like steer us directly into just using this specific SQL command at our best practice, and use the command in order to just like produce the result here. But in order to do that, let's first have a look at how this actually works. And for that, we're going to have a look today at tutorialspoint.com, SQL left joins.htm. And in a more or less concise version, they write about the syntax and how it actually works. The SQL left join returns all rows from the left table, even if there are no matches in the right table. This means that if the on clause matches 0 records on the right table, the join will still return a row in the result, but with null in each column from the right table. So it's just like not initialized. This null means that a left join returns all the values from the left table plus a matched value from the right table, or null in a case of no matching join predicate. Here's the syntax. Select, and then you got the table 1, table 2, or further tables. From table 1, left join table 2. On table common field equals table 2 common field, and that's basically our key, right, where we want to combine them. Example: consider the following 2 tables, and we got like a customers table, and then we got an orders table. That's basically contains exactly to our first question that we had, and then the common ID between 2 of them is the customer's ID, right? So then here we got like select ID, name, amount, date from customers, left join orders. On customers ID equals orders dot customers ID, and then this will give us the result, and we can see that 5, 6, and 7 have no amount and date because they end 1 because they are customers but have not ordered in the order table. That's all to it. So now let's have a look at the solutions being proposed to those three SQL questions. MySQL left join on, let's check this again, customers who never order. Since its SQL is way more concise than what we are used to in other episodes, so it's basically like a one-liner where you really just need to make sure that all your elements are ticked off correctly. Select CNAME as customers from customers, our customers table. C, left join, orders, O, on. And then here's our key thing where we basically find our key in first table and the second table. C.id equals O.customer ID, where O.customer ID is null. And here's basically the selection. That's the interesting part, that once both tables are joined together, we select those names where the resulting customer ID is null, meaning where we have like these additional tables, this additional table rows with columns that had to be filled out with null because their row did not exist in the second table. And that second table is basically the orders table. So we have all the customers merged together with all the orders, and then there are some rows in the table that have null elements in those columns, and then we just circle down those columns and return them as a name. Very concise, very neat, and powerful in terms of just like retrieving data and providing them. Next up was the salary question. Select D, name department, E, name employee, E, salary, salary, from employee E. Left join. Select max EE salary, max salary, EE department ID from employee ID, group by department ID. Hey. On E department ID equals A department ID. Here again it's like that theme where we just search for the key in both tables and equate them, and then use that as a method to basically join them. Left join, select ID, name from department D, on DID equals E department ID, where E salary is a max salary, right? So we wanted to search for those that have the maximum salary in a certain department. And DName is not null, and EName is not null to weed out corner cases. And third up, combine two tables. Really just like the most standard form as possible, just combine two tables to write them together. Very concise, can be written as a one-liner. Select person.firstname, person.lastname, address.city, address.state. From person left join address, so we get person and address. On person.personid equals address.personid, which is like the key thing. And they always want to steer us in the direction, you know, that the idea in the second, the ID in the second table is not the main ID in the first table, but it's still somewhere in the table, right? So our main ID in the first table is some ID in the second table, which is the key thing for us to kind of be able to equate and then to just join those two tables together and be able to output any information from that join table as needed.